Hey guys, in the last video, we figured out that the side-side-side triangle congruence theorem works, that for any two triangles, if we know that the three sides of one triangle are congruent to three corresponding sides of another triangle, then the two triangles are congruent. We don't need to know any of the angles as long as we know all three of the sides. Let's take a little bit deeper look. So here I've left up the three sides that are congruent and the triangle congruence statement. Okay? If we could take this picture and if we could separate these two triangles, and I wish I had a cool animation to do that, but let's just try to do it by hand. Okay? So if I took this triangle and kind of dropped it down here, I know it's not a perfect drawing. And then if I separated this triangle and kind of dropped it over here, okay, it would look like that. So I kind of just separated the two triangles. I deconstructed the diagram. Okay? And this segment here, right here, LM, that is the shared segment. So I'm going to put congruence marks on that also. Okay, so take a look at this picture here, the deconstructed triangles, and let's look at each one of these statements. Okay? Segment KL, well, segment KL is here. It's the one with one congruence mark. It is congruent to segment NL, the one with one congruence mark. Segment KM, this one here at the bottom with two congruence marks, is congruent to segment NM. Notice we went from K to M, we went from N to M. Segment LM, this way, is congruent to segment LM. So when we name the two triangles that are congruent, K matches up with N. K, this vertex here, matches up with N. The vertex L matches up with the vertex L. And the vertex M matches up with the vertex M. So those are the two triangles that are congruent. Here's a bonus round. How could we change this, or how could we transform this or translate this so that this triangle here would be sitting right on top of this, oriented exactly the same way as this one is. Okay? And technically we haven't learned this yet, but there is a series of rigid motions that we could use. Rigid meaning we're not changing the figure, motions meaning we're moving it. How could we move this triangle so it sits exactly on top of this triangle? What would we have to do? Well, we'd have to slide it over to the left, which is called a translation, and we would have to flip it over, which is called a reflection. We wouldn't be changing the triangle at all. We would just be doing what are called rigid motions. We'd be moving it to the left and flipping it over. Okay? And that's something that you're going to learn later on in the course when we get to transformations.